Okay, right, eh? This surface. Okay, this one. Smaller. All right. This is surface fatigue strength. Okay. Calculate the surface stress. Okay, the pinion. Okay, actually the number of days divided by P. By P, you got 3.17. The gear, 12.83. They are the ratio of the pinion and gear, 4.05. This is the I, dimensionless I, 0.1289. The CP, you can use this calculation or table 14.4a. This is carbon steel. It's going to be, the CP going to be in unit PSI, going to be 2,300 square root PSI. Our K going to be 2,300 square root PSI. FT going to be the same as before, going to be 1657.2. This is the same as the example, the bending, bench stress, B 1.7, P going to be 6/inch. And this is going to be same as the KV, K0 cap. This might be different from you, depending on your assumption. Okay, we insert the value, we will get the value. Remember, this in PSI, this in pound, the DP, B and DP in inch, we got PSI, going to be 9194500 PSI. However, since the surface fatigue life, surface fatigue strength will be in KSI, have to convert to the KSI, 194.500 PSI, nearly equal to 194.5 kPSI or KSI. All right, the FE, we use the equation here, going to be steel, carbon steel going to be the steel. We insert the equation, we got the value 110 kPSI. CLI, 1 over, with target is 1 million. Actually, 1 million going to be 1.1 centi-factor. That means 1.1 centi-factor. CR is not given, equal to 1. At the end of the day, we're going to say it fails. And the 0.622. The taste is still there, but the surface is not good enough. Maybe there's the surface is not as before, and the efficiency of the gear may be different. All right, unlike the bending, is going to fail. It's going to be the two going to be break. Right, that will be the final one. They're going to be 0.622. If we compare this value, for example, I just compare the fatigue strength because fatigue strength we calculate before this going to be certificate is going to be. This is fatigue strength? No, this is not fatigue strength. This is the equation bending stress. Okay, we compare the fatigue strength. We get the safety factor going to be 1.42. Okay, for the surface, it's going to be lower, it's 1.62. Meaning that that's the reason why, as mentioned in here, make sure that it's 1.1, 1.5. When the surface is fine, the bending will be okay. This is, I think, the most critical. All right. I think that about the topic for gear stresses. Okay. Okay. What we have. Okay. Any question? I give you to roughly up to 8:45 to go through all the two example, the refined equation and the surface, as well as the undercut. Actually, that is the what I call it, the design based problem. You have to do to check undercut, you have to do the bending, and you finally do the surface. All right, roughly to 8, they say up to 8:47, something like that. Just to go through the previous example and the undercut. As question, we can discuss that. 8:47. Just go to the previous slide, and then we have discussed if you have any question. 8:47 or 48, 2 or 3 minutes. All right, any question on the refined equation, undercut, interference, and the surface? Any question? All right, any question? Okay, if there is no question, okay, I will proceed with your related to the project. Okay, how we going to handle the project after this? And after that, we're going to go for your any question on the test one. Okay, right? We go to project now. All right. They share the design-based problem. Actually, the design-based problem that we're going to do is everything is okay. Everything is you have to define your the to what to start with. I think the power, you know what the power to transfer, it depend on the output. Okay. For example, let's say in the project, in the project, you have, for example, I did mention here. Okay, let me go to here. All right. This is the major project that you have. Okay, in the project, I think you haven't designed the schematic of the gear schematic drawing of the gear. It's going to be hand sketch. No need to have very good drawing. Just hand sketch, that's fine, but you must be very, very nice. Okay, it's legible, that very easy for you to put in the report. Okay, what you have to do is that if you find out that there is, okay, first of all, okay, you know what the output? The output going to be 5,000 Newton and certain RPM. That will be the power required. Right, that is will be the minimum power required. Okay, and you check the output because you have two. It can be one input or you can have one input or two output. Depend. If you can have one motor, then you can design one straight to the end. For example, let's say you take one motors and you have to reduce to certain RPM. Is it right? For example, the input you choose 1,300 RPM motors. At the end of the day, you have to reduce to 300 RPM. That what you should do that reduce that will be your gearbox. On that gearbox, there will be you do a schematic drawing, just a line drawing, just a simple drawing. But you have to, for example, let's say for one, uh, there may be there's a number of pair of gear to reduce the to make the reduction, the number of gears. Okay. Okay, you just choose, for example, three of you. Okay, if you three of you choose the fastest, medium, and lowest. All right. Okay, and do a manual calculation. That will be your design-based problem. Okay, maybe let's say one of you do the fastest one, the other one will be the manual one, then the third one will be the lowest one. Okay, what I want to see that this is going to be manual. You just follow everything here. All right. It start with the same as I show you here. You can start with interference. Okay, this is going to be your what you call it, your your justification, power to transfer, how many horsepower and so on. Rotator speed maybe different for the highest one. Okay, the ratio maybe input be different. For the medium one maybe different. For the lowest one will be different. That means for the lowest one will be the input going to be slower and the output will be lower. And the faster going to be and that will be different. And you start start to do the what you should do is that you just follow this three things manually. Okay, make your handwritten, but it's very nice. I don't mind handwritten. You don't have to have type or using computers handwritten. What you should do that first of all, you do a check the interference. Check the interference here. Remember, that's the final one. The B is must be in between. You can set the value of B, chapter 15, chapter gear, chapter 4, gear. The B is in between the value of 9 over P or 9 module and 14. It must be in between the value. You must set a certain value. Okay, you can set equal to 13P or 12P or 10 10M, doesn't 10M, 12 or 11, doesn't matter, must be in between that value. That will the B. Okay, check the interference, that the first one you should do. Okay, if for example, let's say it comply everything, all right, that's fine. Okay, then in this case, for example, that you find out that the first one is fine, you can proceed with the stresses. Okay, this is the case that I just show you that, okay, I want is to have minimum as possible. Okay, remember that we can cut the addendum. This is the addendum here by 25%. This addendum and this is the addendum here by 25%. We can cut by 25%. I mean quarter of the addendum. It's allowable to cut the addendum. Okay, that means in this case I cut the addendum on the gear by 25%. That means I can have this value 12 pinion and 15 of the gear. Okay, or you can proceed with this value, the first one, with the contact ratio and so on. This will be the first one. After that, what you do now, you do the bending stresses. Okay, the same thing, calculate the bending stresses. And, okay, in this case, I'm using the B equal to 14 divided by P. That will be the largest B, the largest B. Okay, you can have in between 10 or whatever is on the assumption. Okay, geometry factors. Okay, you had geometry factors, KV, and this. If you do manually, make sure it's going to be nicely handwritten for every one of you. If when you do the first one, that will handwritten. The medium one will be handwritten, and so on. Okay, do get PSI and do the limits. Okay, you have to assume the benar number, the tensile strength and so on. I think this is a bit lower. For a gear, it's a bit higher. 400 and 200 capacitor very low. I think it should be higher to be high strength steel, and so on. Then you get certificate. Even though it's failed here, for example, let's say you find out that it's certificate is failed, no need to worry, just proceed. Because this is going to be your what call it, your manual calculation to check your SL will be correct or not. Then you do the surface one, the same thing. All right. Then you do then you get, maybe it's failed or not, doesn't matter. Proceed. That means even though when it's failed, the surface failed, doesn't matter. Then when you have this manual calculation, this manual calculation will be inserted to the report as appendix. Okay, that will be as appendix. Then what you do now is that, okay, you develop, because I think if you're lucky enough you get it correct, okay, then should do the iteration process. That means, for example, it failed, you need to iteration process. That means you need to have Excel, or you can use programming, or you can use MathCAD or whatever, by changing the value of M. And meaning that it failed, you should use higher M. That means for the P, lower P, that means you have higher lower P, and for M is higher M. Depend. Different. That means you have to have higher tools, larger tools. Because that bending, I mentioned before that the concept of bending going to be like this. That means if you fail, what you do now is you have to increase MC divided by I. It's like you have to make the I smaller by having this one larger. That means to have that larger, P is must be smaller. For the M is going to be larger value. Okay, then you proceed another one until you find out that it's fine. This is the case, for example, at the end of the day, I will find this one, I 24. Imagine for that, imagine when P, you choose the value smaller P, that means the higher going to be this M going to be larger. Is it right? It's a bit different. You should refer the figure. When you have the T, P smaller, T larger, M larger, T will be large. Okay, if you use module, going to be higher module. At the end of the day, I found out that my final will be this value, right? Then you can do on because the iteration process, only 3 of you who do the manual, you insert the value, and only 3 of you work together to develop the one system iteration process. That means one as a system. Okay, then You check the fastest one, what is the best module, the medium, and the lowest, the slower one. Okay, then you find out what is where is the is it the slower have a smaller p or larger p or whatever? Then you should think why that happened and so on. That will be the project. Actually, you just follow the spur gear here, except that, okay, you do manual calculation, make it very nice with handwritten, okay, for each one of you, highest, medium, and lower. Because that, when you do it very nice handwritten, you just insert that into the appendix. You don't need to do twice. I don't want you to type. I don't want you to do anything. You do it very nice, scan, take the image, scanner, whatever, make sure it can be legible. I can read that very nice, that's fine. Okay, actually the appendix is not typed. It's just handwritten nicely, and make sure that when you do that, do like that is going to be inserted to the project. And don't do, okay, I just do like a cakayam, whatever, because I want to do it again. No need, just make it very nice. All right. Okay, then you insert to the to the to the report. Okay, that will be design based. Design based problem. Okay, every single thing it will be you have to make decision, and then the day must be this remember this 1.1 to 1.1 to 1.5. This is 1.1. I think 0.3 considered as 1.1 to 1.5. That will be the final one. All right, that will be the project. How you want to run the project? I want to show you going to be how I going to tackle the project. I want to show this one. This is going to be the planning. That's my word. Okay. Today is I think we're going to finish the lecture today. Okay. As a group, maybe after this, or you have maybe another 2 hours, just discuss the schematic drawing of your proposed gearbox. Whether you want to one input to output. Okay, read. There's you get how many pair of gear. I think there's a few constraints that you have to read. I mean, one pair can be maximum of 10. Okay, the assumption, the efficiency of the gear is 20% and so on. Propose that schematic drawing with a bit of calculation, because it should start with output first, because you know the output. Okay, at the end of the day, you have 2 input, okay, or whatever, maybe 1 or 2. Maybe the configuration will be different. Maybe at the end of the day, you can you do when you finalize the configuration of gear, do a calculation again. Maybe at the end of the day, you might get the maximum load going to be 6,000. That's fine, because I think the maximum load given to you is 5,000. That means if your gear 3,000, that's fine. You have another that you save enough. But the maximum RPM going to be 3,000 RPM. Okay, you can have 25. If for example, you cannot 30, but you cannot go beyond 30. You can have 28, 27, or 25, because I said that in the spec going to be 30. When you finalize, you do all over the calculation again, forward, and from the input forward, what is your final specification of the device? Okay, the maximum load going to be 6,000. That's good, because the maximum load as we work is 5,000. That means the machine is fine. The RPM for the hoist, the maximum RPM for the hoist will be 25. That's fine, because I asked you the maximum 30. That means 25 is good. Okay, if for example you only allow 4,000, that's the problem, because your design to have maximum of 5,000. You should have more load, and the RPM should be lower than 30. That's for sure. And refer back, then that will be the spec for your final transmission. Okay, that will propose you by this Sunday, if not mistaken. Use your. I assume that the leader will be. I assume that use the leader account. The first in the group list that you assume leader. Use the account. I will retrieve that your design from that leader e-learning account. Okay, that will be the first one. Okay, and you can proceed with your, for example, let's say with your analysis of gear here, iteration and so on. Maybe 3 of you decide, okay, let's say A will do the fastest one. Okay, you have the gearbox, right? Okay, you do this the first one, I do the second one, maybe the slower we do the by the third person. And you proceed this the one iteration process here. Okay, while the week and 10, week 11, I proceed with the bearing and tension belt. I didn't cover the major project as for now because I want to cover the topic first, right? Because at the time you are doing like on your own, yeah, analysis on gear, make inheritance nicely, insert to the report and so on. Then we're going to have bolt and welding on the week 12 and week 14. I'm going to give these all three together, the bolt, welding, and in video form, and the project as well. They get 5%. Okay, it's up to you. You should focus this one. Then we just focus on group supervision on the 12, 13, and 14. We're going to go for each group. We have 5 hours. That means I'm going to divide certain hours. Maybe the first week 12 going to be tracer process. Week 13 going to be maybe bearing, bearing and shaft, or the third one will be bearing shaft. And maybe I will choose 3 of you. Maybe one of you have to show me your analysis. Okay, and so on. And finally, on the week 15, you will test 2 and you have to submit at the end of major project. That's going to be carried out. Okay, maybe in the next 2 weeks, we just focus on the bearing and the belt straight, because I don't want you to, there will no group supervision on the project, because I want to finish the topic on the bearing instruction belt first. After that, we just focus on another 5% of the minor project and the major project. Imagine, you have test 2 under 30%, you have group supervision under 30%. 30%, 30%, and this 5%, 65%. Okay, second half, take you 65%. All right, I just stop recording, I think. All right, any question on the project, major project, and topic gear stresses? Any question? All right. Since there's no question, okay, and the third one will be your test 1. All right. Okay. Okay, test 1. Any question on test 1? I give you the Google Drive to the solution. There's 3 scripts, because there are 3 scripts, different solution for each scripts. And that means you have to check which script are you. You're number 1, number 2, number 3, and you can check the solution from that. Any question on the test 1?
No, Doctor.
Okay, right. Okay. All right. Since there is no question, we should end the meeting today. All right, the class today. For those who, for those 7, I can show the QR code. And make sure as a group, you can discuss as a group to come up with your schematic drawing of your proposed major project and submit through e-learning of the group leader. The group leader will be actually number 1 in the list, the group leader. Insert that PDF into PDF file, show some calculation from there. Try your best. It can be handwritten, but try your best to get it very nicely handwritten, because you just insert that whatever you submit to me to the final report. Right. See you then. Okay. Thank you very much. Stay safe and assalamualaikum and goodbye. I will show you the for those who haven't scanned QR code for the scanning. Thank you very much. Assalamualaikum and stay safe.
Thank you, Doctor.
Good.
Doctor.
Okay. Thank you very much.